Hello students! So in this video or a little lesson here, we're going to be talking about factoring out GCFs. Hopefully everyone here remembers exactly what a GCF is. So a GCF, or in other words, the greatest common factor, is the largest factor that a group of two or more terms have in common. I'll show you just kind of real quick what that looks like with just finding the common factors and of course the greatest common factor for a group of two or more terms. Please remember, guys, that the number one is a common factor for every numeric or algebraic expression that there is. Again, so whether we're talking about just a constant, a number by itself, or some type of expression that also includes variables. Again, one is a common factor for every type of expression, period. Yeah. Okay, so next we're going to just look at determining some GCFs, or greatest common factor. So let's look at what is the GCF between two numeric expressions, two numbers like 72 and 112. So let's see if we look at both of these numbers. And it may help some of you to actually write out the factors. Alright, so here we've listed out all the factors for 72 and we've listed out all of the factors for 112. So as you can see, they both have some factors in common. Like again, they both have the universal factor 1 in common. They both have 2 in common as a factor. They both have 4 in common as a factor. They both have 8 in common as a factor. So, out of these factors that they have in common, the 1, the 2, the 4, and the 8, let me make sure there's no more, nope, no more. So out of those factors that they have in common, common factors, which one is the greatest common factor? The greatest common factor between those two numbers is 8. All right, so again, the GCF there was 8. So we can find the GCF between numeric expressions like that, and we can also find the GCF between algebraic expressions that actually have variables as well. So again, not only just numeric expressions or constants, but also we can find the GCF between algebraic expressions that have variables. So let's say that we were trying to determine the GCF, or greatest common factor, for these two expressions here, or for these two, and again, we can't really call them terms right now, but let's say that we're trying to find the GCF for these two expressions. And so what we would need to do is sort of similar to what we did with just these numbers. So we still want to write out the factors for the numbers, and then what I suggest doing for the variables is just writing out the variables as repeated multiplication. So again, I suggest writing it out like this, with the number and writing out the factors of the number, and kind of writing out the variables like this. Again, x to the third is the same thing as x times x times x. Remember, it's repeated multiplication. There you have 3 x's. Okay? So, guys, I just want you to realize that I have changed this number here. I got it underlined in blue. I've changed that to 126. Again, before I had 124 written, and I've changed this number to 126. Okay? So if we look at all the factors here of both of those, first, let's just look at the factors of the numbers, right? So if we look at the factors of the numbers, what we have, we can see quite a few common factors. 1 and 1, 2 and 2, 3 and 3, 6 and 6, 9 and 9, even 18 and 18, right? Let's see, is there anything higher, any other common factor that's higher than 18 and 18? Nope, I don't see any common factors that are larger than 18. So part of this GCF is 18 here. A part of our GCF with just the numbers is 18. We also have to consider the variables. So notice how we've got here 3 x's and we've got 1 y. And with the other expression we have 7 x's and 4 y's, right? So how many x's do they have in common? How many x's do each expression have in common? Okay, well, we see 3 x's here, and we see, okay, there's at least 3 x's there, right? So in common, there are 3 x's here that they have in common. 1, 2, 3, and 1, 2, 3 x's here that they have in common. All right, what about the y's? So we can see that the y's, the amount of y's, or the number of y's that they have in common. This one has 1 y. Okay, well, this one has at least 1 y. So we see that they do have y in common as well. At least 1 y that is in common. Okay? So if we put it all together for this particular example or problem, then we can say that the GCF for these two expressions, we can say that it is 18 x to the third power y. Again, we can say that the GCF is 18 x to the third power and y, because those are the greatest common factors. Okay. Again, we see 18 is the greatest common factor for the number parts, and then as far as the variables are concerned, we've got 3 x's. That's the greatest amount of x's that they have in common, and that's where we get x to the third from. And then the greatest amount of y's that both expressions have in common is just one of those. So that's y to the first power. Okay? So again, that's how we would determine the GCF for an expression, an algebraic expression that also has variables. All right, so now we're going to take a closer look at how to actually factor out the GCF. So we've looked at how to determine what the GCF is, but now let's look at how to factor out the GCF from an expression where you have 2 or more terms in that expression. Remember, terms are parts that are separated by a plus or minus sign. All right, so let's say that we were looking at this example here, where you were asked to factor out the GCF of this expression here. Again, we see that this particular expression happens to have 2 terms. Technically, it's a binomial, and there are no constant terms here. These are all variables. The coefficient for each one is 1. And so if we're going to factor out the GCF here, we need to just deal with the variables. And again, like I said, you don't have to do it my way, where you write it out the way that I write it out, but again, I like to write it out where you can see exactly how many variables are there. Okay, so there's 1 W, there's 1 V, there's 3 X's, 1, 2, 3. All right, and again, the same thing with this one. There's 1 W, there's 2 X's, and there's 1 Y. So if we write out those factors, or write out variables as repeated multiplication there, then we can actually determine what the GCF is. All right, so when we do that, when we write out those exponents as repeated multiplication, we see exactly what they have in common. So we see that in each term, the one on the left and the one on the right, they each have a W in common, 1 W in common. they also each have two x's in common. So they have one w in common and two x's in common. Now, so what I've got circled or in boxes, that is technically the GCF. Now, I'm going to write here, just for your knowledge. Yeah, okay, that's not what I was trying to write. Just for your knowledge, I'm just going to write exactly what the GCF is. Of course, the GCF is WX squared. So again, that is our GCF. But if we're going to factor out that GCF, what we're going to need is to write out. We're going to need to write out it like this: WX squared times something, right? So in other words, what is left over when we factor out the WX squared? And I would almost say that one way that you could do that is really just to look at the stuff that we have in boxes here. We have the W in boxes, we have these two X's in boxes. What is not in the boxes, right? You can see here that the V is not a common factor and the X is not a common factor in the term on the left, right? So those things that were not a part of the GCF, the V and the X in the term on the left, that is what we can do as what's left over in that left term. And then on the right, in the right term, what's left over, first off, remember that this is a minus here. What's left over there is just the y. Again, if we literally take out, give me a sec here, if we literally take out these GCFs, take out the GCFs, right? We can see what's left over: the V, the X, and the Y. Now, I believe that one of the videos on Khan Academy may show you a different way. Ooh, that's sloppy. All right, awesome, wonderful. All right, so again, one of the videos on Khan Academy may show you a slightly different way of sort of looking at it. And what they may do on Khan Academy is they may write it out sort of like you're doing a box method type of thing. And so let me, I'll possibly show you that way, possibly with another example. Well, folks, I hope that this video has been helpful. And so we are going to look at a few more examples in the next video, in part 2 of this video. So stick around for that next part. Again, we'll look at a few more examples of factoring out the GCF. I do hope it's been helpful to you. That's all. Part 2 up next.